All right, so I'm pretty sure I feel like this is the first video I'm doing for Algebra 2. I'm not sure. But anyways, today we're talking about transformations of quadratic functions. So we're basically done with chapter 1. We went over just what are transformations, and we went over transformations of mainly absolute value functions, but some of the problems we did also were using linear functions. Remember, a linear function is going to be your line, your straight line, your diagonal line. Your absolute was our V-shaped graph. And what we did was we determined what transformation was happening in the problem. When they asked you to describe it, you're saying, well, if you had the absolute value of x minus 3, we know that this one was going right 3. If we had the absolute value of x minus 9, let's add a 2 in the front. We know that this was a vertical stretch by a factor of 2, and then we also know that it was down 9 units. And that's all we were doing. You did some problems where you had to use the correct transformations to match up the graph with the new one, which was on Delta Math. And then you also had some where you had to match the notation with the graph. Make sure, do you know your transformations? And then, of course, you spend a while on creating functions from new transformations. So it's like here's a function f. You need to make a new function that's called g using this given transformation. We're going to end up doing that again, but this time we're not going to be talking about linear absolute values. We're going to talk about strictly on quadratic functions. As I'm writing these down, I need to make sure that you guys write it down as well. What I wrote down before, the linear and absolute stuff, you don't have to write that down, but make sure you get the title and make sure you start writing what I'm getting on the board right now. So this is going to go in your notes. Eventually what's going to happen is we're going to go back and I'm going to do like a mini chart on here. So that chart that you guys did in your notes, you need to go back to it and add what I'm going to add eventually on here. So a quadratic function is a function. It's crazy how they started that definition out. That can be written in the form I'm gonna write it down here. F of x equals a times the absolute value of x minus h squared plus k. So a quadratic function is a function that can be written in the form f of x equals a times the parentheses of x minus h squared plus k, or f of x equals a x squared plus bx plus c. Both these forms have a name. We're going to go more into descriptive about this form, but this is what you call your standard form. So your standard form, so again, it's ax squared plus bx plus c. We know that this is a quadratic function just by looking at it, because when in standard form, so when you're told to write something in standard form, your variables have to be in alphabetical order and your exponents have to be in descending order, meaning you start with the highest exponent and go to the smallest. So I know this is standard form for a quadratic function because my highest exponent is 2. Quadratic functions have their highest exponent or degree has to be 2. If it's not 2, then it's not a quadratic function. A quadratic function also creates a U-shaped curve so a quadratic function, whenever you graph these, you know that you're graphing a quadratic function, or what you're dealing with is a quadratic function, because it creates a U-shaped curve. That's what we call a parabola. Not a parabola, a parabola. Now, I use the word, you're gonna hear the word parabola a lot, so you need to know what we're talking about. So again, when we're talking about a parabola, we're talking about the shape of the graph, or we're talking about the graph itself. So always remember that parabola is our U-shaped graph, which means if we're talking about a U-shaped graph, we're talking about a quadratic function. Just like linear functions, linear has the word line in it. So it's, our graph was a line. Absolute value, the graph was a V. So you can tell that it was an absolute value graph. A quadratic function, again, is going to be a U-shaped graph. So I want that in your notes. From here on out, so stop writing your notes. From here on out, this is going to be the chart that you have in your notes. So I'm going to kind of try to do it again. Again, like I said, make sure you left space, because we're going to keep adding on to that chart. So your chart should look like this. You should have your transformations, your function, if I can spell function right, your function notation. Let's make that one smaller. And now, so here in your chart, you had transformations, your function notation, and here we had absolute value. I'm not going to write the absolute value box down, because now we're not talking about absolute value. You need to add another column, but this one, we're talking about our quadratic functions. And so when we talk about the quadratic function, again, all these examples are going to be a transformation on the parent function. So as of right now, we're dealing with f of x is simply going to be x squared. This is our parent function. It's the most basic quadratic function you can get out there. There's no transformations happening in this function right here. So the first one we're going to start with is our vertical translation. Sorry for not writing it down. You should already have these two columns in your notes, but I'm going to go ahead and go over it again. Your function notation for this is y equals f of x plus k. Again, vertical transformation, a vertical translation means we're going to be going up or down. Again, going up or down is going to affect my y values. That's why the plus k is on the outside, because anything that's going to affect my x values are going to go where my x is at. Because it's on the outside, it's going to affect my y values. So I'm going to do this one a little bit different. I'm going to give you, so this can help us more along when we're doing the transformations for later on problems. I'm going to tell you that for this problem, k is 4. K is equal to 4. So what I'm going to do is I'm going to take my function notation, but instead of k, I'm replacing k with the given value, which is a 4. Because it's a positive 4, when I add into replace k, it's just going to be plus 4. Again, all we are doing is rewriting the transformations. Well, bad. All we're doing is taking the function notation, the function, and writing it with this given transformation. Now that I know that I'm going up 4, I can replace f of x with what it's equal to. F of x is equal to x squared. So it becomes x squared plus 4. I can't do anything else, so this right here is my function. So if you're given a problem like y equals x squared plus 4, from here you can tell me what that transformation is. This transformation is up 4 units. That is what this one right here is telling us. We're going up 4 units. Again, remember, if it's a vertical and it's happening on the outside of the parentheses, remember, whatever number they give you, that's the number you're working with. The tricky one is when you get to the horizontal transformations and it's inside the parentheses. It's always you always want to think about it as being the opposite. So if this is a positive 4, this is automatically up 4. So this next one, I'm saying k is equal to -7. That means in my notation, anywhere I have k, I am replacing it with -7. And then I'm going to replace f of x with what it's equal to, which is x squared. So it's x squared minus 7. So again, this is my new function. This is my transformation on the parent function. If we were to go graph this function, you will see that the graph would go down 7 units. Again, these are what you should be writing in your chart. That way you have something quick to look back at as an example. So again, I recommend pausing this video so you can write this one down.